Hello there, friends and neighbors. I'm going to pick up where I left off in the previous video with multi-way ANOVA, and now I'm going to show you how to run a repeated measures ANOVA using RCommander and EasyR. This is in the context of Real Data Homework 12. So I've already got the assignment open, I've already imported the test scores data set, and now I'm ready to rock. I'm going to read question 7, the last question. For this exercise, the most recent test scores data set is what we're going to use, and I'm going to use the Holm pairwise comparison, doing my repeated measures ANOVA. So let's just go ahead and dive in. Put away the graph from the last one. Statistical analysis, continuous variables, repeated measures ANOVA. And the repeated measurements are what? Test 1 through test 6. So test 1, 2, 3, 4, 5, 6. You're going to need to be able to use the control button to make this work. So if you're using VMware with the Windows 10 app, it will not work. You need to use the desktop version if you're using Windows 10. If you're using a different operating system, none of this is a problem. And if you of course, as always, can do it if you just install R directly on your own computer. So now I'm going to click on Pairwise Comparisons with Holm. Okay, and then I click OK. And it gives me this awesome graph where I can see that the sample mean is going down. It's gone down every test from 1 through 6. Now, I don't know if it's statistically significant. That's what I'm going to look at next. So scroll up to go get to the ANOVA results. Here they are. The effect of time, that is, test taking over time. I go look, here I've got 5 degrees of freedom for the numerator, 270 degrees of freedom for the denominator, and my F is 20.746. 20.746. Now the p-value is so small that it's showing that it's less than 2.2 times 10 to the power of negative 16. I'm just going to copy that and paste it, and that's fine. Very, very small p-value. That's, of course, statistically significant, and that shows that, yes, test scores change significantly over time. That's what that means. Now, if there is an effect, which means are different from which other means? I need to now look at the Holm pairwise comparisons to answer that question. If you forgot to choose the Holm option, run it again. If the p-value is less than 0.05, reject HO and conclude that the difference is significant. And we need to decide which direction. Well, the direction is easy, because I can see they're dropping every time. So this is going to be easy. Now, I'm going to go look at my Holm comparisons, which is the last output down here. And I'm going to look at, it says 1 to 2, 2 to 3, 3 to 4, 4 to 5. I'm not going to look at every possible pair. So test 1 to test 2 has a p-value of 0.015. That is significant. And since test 1 is higher than test 2 in the graph, that's how I know that I conclude that this is different. Test 1 is higher than test 2. Comparing 2 to 3, I get a p-value of 0.26, a large p-value. Not significant. Comparing 3 to 4, again, the p-value is large, so I don't reject HO. Comparing 4 to 5, I see the p-value of 0.668, large, I don't reject HO. And finally, comparing 5 to 6, I see the p-value is very small. And so that is different, and so I need to look at to see which one is larger. 5 is higher than 6. So 1 is different from 2, 5 is different from 6, and the other differences are not statistically significant. And that's it. So test scores are dropping over time. There's a major drop from test 1 to test 2, and another from 5 to 6. And that is it.